continuing here in 3.5 in Trig on maximum and minimums, we just got done figuring out how to rewrite it with parentheses and squared using completing the squares in the last section on 3.5. We also went over that in 3.4 with transitions, writing it in that vertex form. And I'm going to show you how you can use that vertex form to find the maximum and minimum now.
You broke my nose!
So this is a standard form for quadratics. Y equals a times the quantity of x minus h squared plus k. You're going to have to remember that.
The dread pirate Steve be in no man's debt. I'll make a...
So I'll write in standard form and find the vertex. So once again, this is just like the last problem. So I need to do completing the squares on this problem. So here's what I'm going to do. I'm going to separate this. I'm moving the number out because according to that, that's your k that's out by itself. And whatever I add in here, I need to take away, which is why I put the subtraction sign there right away. So I put this in parentheses. But once again, you can't do completing the squares of the number out in front, so you have to take that 2 out of there. So to take that 2 out of there, I'm going to divide these by 2. 2 divided by 2 is 1. Negative 6 divided by 2 is negative 3. Okay. So now, according to completing the squares, it's b over 2 squared. Well, b in this problem happens to be a negative 3. So it's negative 3 over 2 squared. Negative 3 squared is 9. 2 squared is 4. So it's 9/4. However, whatever I'm adding over here, I need to subtract. And because I have a number outside of it, I actually have to distribute that through. So 2 times 9 is 18. I still have the 4 on the bottom, so I'm really subtracting an 18/4 on the other side. Okay, so now I need to rewrite this with the factors. And the beauty part about this is, remember, with completing squares, whatever's inside of here is your factors. Negative 3 over 2 is your factor for this parentheses. So this side will just be x minus 3 over 2 squared with a 2 out in front. This, however, I have to put together 4 minus 18/4. Very simply put, if you plug that in your calculator and go to the math and then press frac, it'll tell you your answer right away. But for those of you that don't have a graphing calculator, you're going to have to find common denominators. So I'm going to have to multiply both the top and the bottom by 4. So I get 16 over 4 minus 18 over 4. I get negative 2 over 4, which is negative 1/2 when you simplify it. So, like I said, this is your factor. This is x minus 3 over 2 and x minus 3 over 2, which means it's x minus 3 over 2 squared because you have 2 of them. That 2 is out in front, so I put that 2 out in front. And when I combine those together, I get negative 2/4, which, remember, simplifies to negative 1/2. And there is your standard form. So the vertex, how do you find the vertex? The vertex is actually pretty simple. It's whatever makes this 0, and then whatever this number is. Or another way to look at it is, what's the opposite of this number? The opposite of negative 3 over 2 is positive 3 over 2. And then you take whatever the number is on the outside, and that is your vertex. So to find the vertex, you take the opposite of h, and this is your h. So the opposite of h would be 3 over 2, and k is whatever number is outside. So it would be positive 3 over 2, negative 1/2. And that would be where your max or min is in this graph. An easy way to know is this is actually the minimum point, and I can tell without graphing by looking at the equation. Because it's a positive x squared, that means your parabola is going to go like this. And if your parabola goes like this, that means the tops go to infinity. The tops go to infinity, meaning we don't know where the max is going to end. We have no idea. We do know where the minimum value is. So this is going to be the min. If there's a negative out in front and the graph went like this, then, because that's what negative parabolas do, now we know that it goes down to infinity, meaning we have no clue where it's going to end, where the minimum is, but we do know the max would be up here.
I feel like I'm taking crazy pills!
So I'll write this in standard form as well. So keep in mind, like I just told you, this is negative out in front, meaning the parabola goes this way. So the vertex point is actually ending up going to be a maximum point that we're finding. So before we even do anything with this, we know it's going to be a max. So I separate this. I put these out in front, and remember that 8 comes out here by itself. I'm going to group the front in parentheses. This right here is minus because whatever I add to this, I have to take away. So this is a negative. I'm going to pull a negative out, and when I do that, that becomes positive, and that becomes positive. So the formula states b over 2 squared. So b is 2, so it's 2 over 2 squared. 2 divided by 2 is 1. So really it's 1 squared, and 1 squared happens to be 1. So whatever I add to this side, I have to take away, but this is a negative 1, right? I have to take whatever's from the outside through, which means it's 8 minus a negative 1. So over here, minus a negative becomes plus, so that's really a 9 on the outside, and remember whatever's in your parentheses is your factor, so all of this is x plus 1 and x plus 1. So it's actually, because there's two x plus 1's in here, it's x plus 1 squared, you have a negative on the outside, and that's a 9. So how can you find your maximum point? I said it's maximum because the graph's going down. It's the opposite of h, which is negative 1, and k, which is 9. So your maximum point is negative 1, 9.
You're trying to get crazy with it.
Find an equation of a parabola that has a vertex of 2, 3, and a vertical axis and passes through the point 5, 1. Okay, so here's what this is actually telling us. In the formula, the vertex point is h and k, so it's telling us h and k in that formula. It's also giving us some random point that it passes through, which is 5, 1. That's x and y. Well, if you remember the formula, here's your formula. This is telling me y, it's telling me x, it's telling me h and k. The only thing it's not telling me is what a is. So I need to plug in every single one of these values into the standard form for quadratic to find a first. Once I find a, then I can set up what the actual equation is. So that's what I'm doing. I'm plugging in all the values that I have. So 1 in for y, 5 in for x, 2 in for h, 3 in for k. So when I do this, 5 minus 2 is 3. 3 squared is 9. So really my equation is 1, 9a plus 3. So I minus 3 to both sides to get negative 2 equals 9a. Divide both sides by 9. And I figure out that a is negative 2/9. So now I take that a, because I have a, and I plug it in. So negative 2/9, I plug in a. Boom. There it is. But in the equation of a line, you don't plug back in for y and x. You just leave y and x as they are. You plug in the values of for h and k to get your final answer. So h was 2, plugged it in, and k was 3, plugged it in, and there's your equation of the line for example 5.
Dang.
So vertex of a parabola, that is where we hope to finish up. When we come back, I'll stop here and we will finish up our notes hopefully on 3.5 with max and min when we come back.